Hello viewers and my dear students. Welcome to session 8 on thermal analysis. We are doing a demo on simple 1D heat conduction problem with convective heat transfer at one end, typically called as composite wall problem. This in the previous session we are done by theoretical methods. You see here, this was a problem. Okay, this composite wall problem had three layers. One is 0.3, 0.15, 0.15. This outside temperature was 20 degrees. This inside you had this convective boundary condition given with this T. This is 800. Okay, this is 800, not 870. This is the fluid temperature was 800 and the convective film coefficient is 25 watt per meter square and all that. We have found out theoretically the surface temperature here in the previous session. We have found out the surface temperature was 304.8 at this, or you can call it TS or T1. At T2 it was 119.1, we have found out. At T3 it is 57.2, and this T0 anyway it is given for it is 20 degrees only. Okay, and you should know also this K1 is 20, this thermal conductivity for this surface, okay, is 20. For this it is 30, thermal conductivity 30 watt per meter degree centigrade. This is 50 watt per meter degree for this. This is the thing, and we have found out. And we have also found out Q by A to be 1 Q by A, that is heat transfer rate through the composite wall, that is heat loss to the surrounding, was 12380 watt per meter square. Okay, considering the that is convective boundary conditions also. Okay, that is 12380 was the thing. This was done earlier in the previous session. Now we have to do the verification using Ansys. That is the thing what I do now. Okay, now as usual we'll go in the same way. Clear, start new. Okay, we'll do this and fit, then file, change job name. This you make it a habit, change job name. Okay, one day conduction plus convection. That is, it is not only conduction, but also you have a conduction plus convection boundary conditions and all that. You have something, some name given for change job name. Okay, this you give, then say okay. Okay, then here in the change title, no, change title, whatever they give, whatever you write, you will get. Now you can write it in detail here. This is composite wall problem. Correct, you write composite wall problem. This is thermal analysis anyway. Thermal analysis. Okay, with convective boundary conditions. Okay, whatever you do this. Okay, with convective boundary conditions, it has its limitation. If it becomes length, it has cut off. But anyway, you can make it as composite wall problem, thermal analysis with convective BC boundary conditions. Okay, and here Gurdat one day, this is a new file. Now once it is in the new file, the new log file would have been created, and whatever you do in this problem, would have been pasted to Gurdat one day. Okay, did you follow? This is change job name. I have done no change job name. This would have been done. All would have been pasted to this. See here, you know very well there are two methods of doing. One, what we are doing is graphic user interface method. And there is log file operations. That means log file operations is you can know the log file what you would have created in the same way. Now the Ansys is creating a log file for you. If you understand that, you yourself can write a log file directly in Word or in any such thing. In Microsoft Word you do, copy and paste it here, you get the answer. Okay, that is the thing. Right now don't worry about that. For the examination and all that, what you have is GUI only, graphic user interface method only. Okay, graphic user interface method, not log file operations. I'll show you, I have shown you already in the earlier sessions and all that. Okay, how to do log file creations and all that, when that is in the previous sessions I've shown you. Okay, now you see here, now here I created new job name, that is Gurudhar one day, and I've changed title also. Now preferences you go, compulsorily you take thermal. Okay, then preprocessor, you take element type. Okay, add, edit, delete. Okay, you add thermal solid, that is plain 55. Okay, quad 4 node 55 only you take. Okay, you say, then you just say close. Okay, then under material properties you be careful. Material models, and under thermal conductivity, isotropic, first one has a thermal conductivity of 20. 20 you do, say okay. Then second one, material new model, material ID 2, okay. This isotropic, you give it as 30. Just say okay. Then material new model, you say this is 3, okay. Now the third one is 50. Okay, you verify this. Now material exit, you verify whether what you have entered is correct or not. List properties, all materials. One is 20, as per the problem it is 20 only. Next is 30, next is 50. I think it's okay. Okay, then you can go ahead with the modeling. Okay, now this is okay. Then once you have entered the properties here, then go for modeling. Modeling, create, directly you create the areas. Areas, rectangle by 2 corners. First layer, you have it as 0.3, 0.3, height you take it as 1. Did you follow? Just say apply. This is 0.3, this is 1 you take. Okay, 1 you take, you get this. Then you see here, there is one more, offset work plane to key points you do. This work plane you bring it to this end, that is this key point. Just say apply. That means work plane has come here. This is X, this is Y now. Okay, now in the same way, rectangle by 2 corners. Okay, here width is 0.15. 0.15. Height is 1 meter. Okay, this is width is 0.5 for the second layer, 0.15 meter. This is 1 meter. This you write it as this. This is 0.15. This was 0.3. That's okay. This is 0.5. This is 1 meter and all that. This you do. Again, work plane, offset work plane to key points. You push it to this now. Work plane, you push it to that. You just see it has pushed to this. Now rectangle by 2 corners. Now again, this width for the third layer is also 0.15 and this is 1. Okay, just see it is done. Okay, now 3 layers. This is 0.3 by 1. This is 0.5 by 1 meter. This is also 0.5 by 1 meter. Now we'll push this work plane back to the original place. Offset work plane to origin of active coordinate system. Now it has come to this point. Okay, now you know very well, you have created three areas. Okay, three areas. One, the first that is in the composite wall. First area is this. This is K1, as you know, it is 20. This is K2, 30. This is K3, 50. This thickness is 0.15, 0.3. This is 0.15. This is also 0.15. In that way, done. Now, the most important thing here is, in thermal analysis, unless you glue the areas, okay, unless you glue the areas, you won't get the interface temperatures properly. All will be wrong if you forget to glue the areas. That is why, do operate, Boolean, take glue, areas you take, this area and this area, you say glue. Okay, this and this. Again, glue areas, this area and this area, again you glue it. Okay, that means you have glued this area and this area. Okay, this is very important. Don't forget to do this. Then under meshing, no, meshing, you see here, mesh attributes, I have to assign material 1 to this, material 2 to this, material 3 to this. Material 1, that means this should be first material 20 watt per meter degree centigrade. This is 30. This is 50. In that way, you have to attribute meshing, okay, mesh attributes, picked areas, you say, picked areas. First I'll pick this area. I'll just say, okay, this is one, no. Just say apply. Okay. Then pick this area. Apply. This should be 2, no. 2 you do. Apply you do. Then you go for this area. Apply. That should be 3, no. This is 3. 3 is a thermal conductivity of 50. In that way, now once you have done all that, you just say okay. Okay. Once you've done this, you assign this as material 1, that is 20 watt per meter degree. This is 30 watt per meter degree centigrade. This is 50 watt per meter degree centigrade. That is, thermal conductivities have been assigned for this composite layer. That is layer 1, layer 2 and layer 3. Now you see here, meshing is an art. I'll tell you, meshing, size controls, no. Size controls, you can have any sign. I told you, more the number of elements, more accurate the answers will be. But still, we'll have our own limitations, because if you make it very fine mesh, it will take too much time to respond. That means to get the answers. Now I'll do that manually. I'll do the operation here. See here, what I'll do, there is small manual size, lines, picked lines I'll go, okay, this and this, okay, I'll do, I'll have around 20 divisions there, okay, number of divisions 20, I'll say okay. In the same way, picked lines, this and this, I'll say around 10. Okay, I'll say around 10. Okay, then picked lines, this and this, I'll say it is around 30 divisions here. Okay, once you do this, this is 30 elements have been created here. Here 20, 10, 10 and all that. Now what you do is, mesh, areas, free, you just say pick all. See here, beautifully you have got the mesh. Okay, now this meshing has been done. Okay, now this, up till here it is called preprocessing. Now we'll go for the solution phase, where we'll apply the loads and then solve this problem. Okay, now we have come to the end of session 8. Thank you very much friends for watching. We'll continue this problem in session 9. Thank you.